Good. I'm going to introduce our speaker today. We are fortunate to have with us Roger Duncan. Roger is actually on his way to Brazil, so he was taking some time out of his day. We're the least exciting part of his day, I think, because he's on his way to sunny Brazil. But Roger is currently he's a research associate at the Center for International Energy and Environmental Policy here at UT. He's also the former general manager of Austin Energy, and has served in executive roles within the City of Austin government, also in Austin Energy government, but also he's been a member of the Austin City Council, elected twice in the 1980s. He's also the chairman of the board of the Pecan Street Project, and he's going to speak to us today about the future of electricity. We're very fortunate to have him, so please join me in welcoming Roger Duncan.
Thank you very much, and thank all of you for the great work that y'all are doing here. Unfortunately, I've not been able to attend the conference, but I sat in a little while, and you're doing some really excellent work down in the weeds, dealing with the real technical and political and regulatory issues around this. But I'm going to provide a little comic relief, if you will, and take you up to about the 50,000 foot level for a while. And talk about energy in general and mega trends that I see in energy. And I'm going to start out about as high level as we can get and remind you that everything is energy. Not just the electricity you're talking about this conference or the gasoline in your car, but the tables you're sitting at and the clothes you're wearing, the food we just ate, the light by which we're seeing each other now. It's all energy. And when we start talking about our energy crisis and the energy problems and regulation of energy and energy independent and all that stuff, we're really talking about just a very small piece of our overall world where we take certain forms of energy that we label fuels, and then we transform them into other forms of energy that we label work. And that's what our economy is. We generate electricity to run our lights and computers and electric motors and such. We fuel an aviation industry. We power cars and trucks, and we move manufactured goods all around the globe with container ships and trains and planes. And most people realize, I think certainly in this room, that this work is fueled by basically four fuels. Oil, gas, coal, and nuclear provide over 90% of all the energy for the economy in the United States. I think what most people do not realize, however, is that there are just four technologies that convert all these fuels. Here they are. The steam turbine produces over 70% of all the electricity in this country, and most of the remaining 30% is produced by the gas turbine. The aviation industry the modern aviation industry is fueled by the gas turbine, except for the propeller planes, which are fueled by the third technology, the spark ignition internal combustion engine, which powers all of our cars and light-duty trucks. And then the heavy-duty trucks and the container ships and the trains and all are powered by that fourth technology, the compression ignition internal combustion engine. A couple of things about these four technologies. The first one I've already mentioned, which is they run on fossil fuels. Except for some nuclear in the electricity industry, everything's powered by some form of a fossil fuel. But the second interesting thing to note about these technologies is that they are all 19th century inventions. These are the inventors and the dates of inventions of these technologies. They're all in the 1800s, one's in the 1700s. But today, finally, in the 21st century, we're moving away from fossil fuels and from these technologies. Here in Texas, we have learned to generate electricity by using the wind generator, invented by Charles Bush in 1888. And now we can take sunlight and directly turn sunlight into electricity using the solar cell, invented by Charles Fritz in 1883. And in the future, we will take water and turn water into electricity using the hydrogen fuel cell, invented by William Grove in 1839. Okay, so the reality is that although we've made these technologies much more efficient and we've mass-produced them, we have not found a fundamentally new way to either generate electricity or move our transportation sector in well over a century. And I'm not certain that we will. But that's not saying that our energy industry is not changing, because the way that we use energy and move it and manipulate it and store it and monitor it is all changing and changing extremely rapidly. And what we're fundamentally changing from is this: a conventional energy system where we have large power plants, mostly fossil fuel still, moving electricity in one direction along a transmission and distribution system that you're discussing at this conference to buildings, either office buildings or residences or industrial factories and so forth, and then a transportation sector running almost entirely off petroleum, completely disconnected from the rest of the system. What we're evolving to is this. I call it a unified energy system. Not only is the utility of the industry changing to different fuels and different types of technologies, the buildings themselves are not only much more energy efficient, they're starting to generate their own power on site. And the transportation sector is finally starting to move away from petroleum to other fuels, whether it's electricity or hydrogen or biofuels and so forth. And all three of these points are starting to be interconnected and not just move information back and forth between the points, but move power back and forth. Whether it's the utility to the house back to the utility, the car plugs into the utility, plugs into the house, energy can move both ways and so forth. It's a unified energy system. And in describing this change, I like to look again at the higher levels of what are the mega trends involved in this energy transformation. And as I was thinking about it last year, I was struck by what my wife does. My wife is a journalist, and she describes events, journalists do, in terms of who, what, where, when, why, and how. And it struck me that despite all the complications, we're really talking about energy conversion events in the energy industry. And the change can be described in the same way. So I want to talk about the energy conversion megatrends that I see happening in the industry. In terms of what is the fuels that we're using, how is the technology that transforms these fuels, where we transform the fuels at, when is the time of the transformation, why is the workload, why are we transforming energy anyway, and then finally, who are the decision makers deciding this? And all of these things are changing. In terms of what, everyone's familiar with the ultimate move to decarbonize and move from fossil fuels to renewable energy. It's happening at different paces, it's different places, and at different speeds, but generally we're moving in this direction. A couple of things to note about that decarbonization. First of all, we're moving from a relatively few number of fuels to many fuels. We've been working with oil and nuclear and gas and coal and some hydro, and now we're starting to add not only wind and solar, but geothermal and biofuels and ocean in the future and so forth. The mere fact that we're adding so many different fuels to our mix increases the complexity of our system enormously. And that's at some of the heart of the problems that you're going to be dealing with. The second thing to note is that in some respects, this transition is going to be slow. This is the transition from wood to fossil fuels from 1600 to 2000. Millennia before this, the main fuel was wood. We talk about coal and oil being in the 19th century and all. They really didn't become the majority fuel until earlier in the 20th century. And the modern fuels of nuclear and hydro really relatively recent. And so one of the lessons here is that it may be a slow transition overall to renewables, more than we're expecting, for several reasons. These energy transitions, if you look historically, they take decades, if not centuries, to fully occur. There are large sunk investments in this current system that you can't simply write off overnight and change. And there are extensive and expensive new infrastructure requirements to make the transitions. Throw in the persistence and adaptability of established prime movers. Gas is the perfect example. The speaker said just earlier, we were writing off natural gas just a decade ago. The same thing is occurring in oil, the resistance of coal. There are a lot of potential for reducing cost, increasing efficiency, and these prime movers that we have fossil fuels staying in place for a longer period of time. And skilled labor requirements. Everyone's retiring, it seems, and I'm an example of that, having recently retired from the electric industry, but in all the energy industry across the board, retirements and skilled labor shortages are starting to show up in everything from maintaining the existing infrastructure to putting into place this new infrastructure. However, I think that distributed solar is an exception to this rule. And the reason I think that is that we should not be thinking of distributed solar as a new power plant. Power plants essentially have to deal with the process of permitting and siting and construction and fuel processing and flows and so forth. And no matter what the technology is, it takes time to transform that industry. I think distributed solar will be much more similar to these things. That in fact the consumer adoption curve for distributed solar could be much more closer to consumer electronics than the power plants. You can manufacture it in manufacturing anywhere. You can move it through our regular distribution system to stores and chains. You can install it locally with relatively unskilled labor. Eventually, we'll see the Home Depot with plug-and-play solar that you can get through, and I think that's just an interim step. I'm fully confident that advanced 3D printers will one day be able to print flexible solar cells that you can throw up on any surface that you want. So distributed solar can be an enormous game changer, different from, I think, the other renewables of geothermal and even wind, utility scale wind and so forth. So what are the technology megatrends? Now, I've talked about the what, the fuels. Now, what about the how? There are a couple of, and you need to be patient with me. My academic background's in philosophy. And I tend to say, well, what are the big philosophical trends here? And one of them, I think, is that we're getting more and more productivity from less and less physical material. And to my knowledge, the first person that really got this and spoke about it was Buckminster Fuller. He called it accelerating ephemeralization. Now, boy, there's a buzzword for you. He was saying that our technology is becoming more and more ephemeral. It's getting smaller and smaller to the point of disappearing. But not just smaller, it is getting more powerful and more productive as it gets smaller. And furthermore, we're learning how to do this in ever decreasing increments of time. It's accelerating. Later, the futurist Ray Kurzweil, even though he doesn't acknowledge Bucky on it, I think picked up the same theme. He calls it the law of accelerating returns. Most of us are aware of one small piece of that technology trend, which is Moore's law, the doubling of power in computers about every 18 months, so doubling of power on a single chip. So more and more productivity from less and less material. What does this lead to? Well, one of the things that will affect energy, I think, is nanotechnology. Nanotechnology is going to produce really low-cost solar cells. And I love to say this, but one day, distributed solar will be too cheap to meter. Hydrogen production from water will be within our reach. Graphene is a marvelous new product, and the thermal and electrical properties of graphene are truly transformative in our industry. Solid state lighting, super strong lightweight materials, transmission lines, energy storage. big list from nanotechnology. Another technology megatrend is that we're getting more productivity from less motion. And this is a principle in physics some of you are aware of called the principle of least action. And several people, the great mathematician Leonard Euler and Leibniz and others first postulated this centuries ago. Where it shows up in our industry is in energy that you're moving from the up and down strong motion of a piston to the rotary of a turbine, much more powerful, faster movement, less motion, much more power, to the power of electromagnetic fields where there's very little material in motion but extreme power. And this trend in our industry is that we're leading to more electrification of our processes and our workloads. And that gets to the why. Why are we doing this? And the major trend we're seeing, I think, worldwide is electrification. Electrification of our transportation system we're starting to move into, computer loads. I remember a decade ago when we were first got the plans for data centers, and we said, this can't be right. You know, there cannot possibly be an office building with a 4 megawatt load that's coming in. And now it's showing up, I think 2% of electrical load now worldwide is from computation, data centers, and it's growing. Electrification of industrial processes, and then robotics, and I'll get into robotics at the end of this talk. Where? The location. Decentralization, major movement here, and you're well aware of it. Won't go into it further, but that's obviously the change in the location of where we're transforming the energy. There's also increased space being used for the transformation to renewables. Because of the energy density of solar and wind and the other renewables, if you're going to do utility scale, it frankly takes up a lot more space than fossil fuels or nuclear and so forth. Now, that may not be an issue. If that space is on top of unused rooftop, it is not a stopper, but it is an issue in other considerations. But that's the where and the location. When is the time. Shifting the time of energy conversion and consumption is a game changer. The buildings, transportation, utilities, these are the various energy storage from all the way from pump hydro and compressed air energy storage to utilities for energy management to bridging power down to power quality, UPS systems. Another major trend that's changing our industry is the embedded intelligence that we're putting into our technology, ranging from sensors and actuators to more precise engineering specifications as we move forward, and that is a game changer. You put a lot of this together, what it shows up as is a continuing increase in energy efficiency and in automation in our industry. Now, who are the decision makers? And at first blush you say, well, same people that's been making decisions before. People are decision makers, right? No, three things here. First, the utility business model is about to radically change and is already changing, but we're at the very beginning of that. Secondly, we have a new prosumer to deal with. We no longer have customers, really. They're starting to catch on. Prosumer is the word that Alvin Toffler coined in his book, Revolutionary Wealth. He combined the word consumer and producer to make a prosumer, and it's because we're starting to produce more of what we use. And then finally, artificial intelligence is becoming more and more the decision maker in our industry. And I'll get into that. Our business models in the utility industry started with Tom Edison's personal secretary, Sam Insel. Hadn't really changed much since that day. We have centralized power plants, transmission and distribution systems. We make money off the volume of electricity that we sell, and we have a regulated monopoly in most places to some degree or another. Future business models, y'all have talked about some of them here. Services versus a commodity, and the utility starting to provide services. Being a broker of distributed power as you start to manipulate from all these different sources. Smaller and more discrete companies. Energy storage, ancillary service companies. Centralized power dedicated to industry. All of these are possible models. They were summarized by Peter Fox Spinner in his book, Smart Grid, a couple of years ago. He said that everyone's talking about either an energy service utility or a smart integrator of all the distributed sources. And I think Peter is right, but frankly, let me be honest here. I've been hearing about this for probably 12 to 15 years. I have yet to see a successful transition from a utility to these other models. And I'm not optimistic that the utility industry is going to be able to successfully transition. I think there are extremely hard times for the electric utility industry. Future role of the grid, coordination, integration among multiple suppliers, broker of energy sales, moving energy among storage and demand, power quality protection. The thing that's missing from here that should be up here is security, absolutely a top role for the grid. The new prosumer that I mentioned, we are producing more of what we consume. Toffler never applied this to energy, an electric utility, by the way. It never entered his book. But to me, the building owners who are going to be both buyers and sellers of electricity is a perfect example of a prosumer. Dynamic pricing will be key, and more the computer interface will develop as the decision maker. We say, we talk in Smart Grid about, we're going to give the consumers information to make better decisions about their power use and so forth. Well, they're going to do that for a week or two, and then they're going to get tired of it, and then they got to have a programmed, automated device that will make those decisions for them, and that's where the decisions will be made. And if we really look at it technically, our electric utility industry is run today by computers. I mean, the temperature is going to ramp up this afternoon. There are going to be tens of thousands of thermostats that will sense a temperature change and turn on a compressor, and the power plants at Austin Energy will ramp up, and our fine folks at Austin Energy, and they are great employees, are going to sit in a control room and watch it happen. Which gets me to the topic of robotics and energy. Robotics we've seen in manufacturing. Service robots are starting to come about, domestic robots. I think we'll see them in building construction more and more. They're a whole new area of energy loads that we really haven't analyzed yet. And this whole idea of ubiquitous sensing and computing and automation, more and more our electrical generation is going to be robo-sourced. Our lines are going to be inspected and maintained more and more by robotic devices such as this. Manufacturing, from solar cells to wind turbines, to inspection of the wind blades with micro robots, controlling of the electric power through the solar, and so forth. Our electric meters now, and our thermostats that are starting to learn your behavior, right? And more you're going to see appliances that are not just passive, but start to learn, can read weather reports on their own, make adjustments, and so forth. The appliances start talking to each other. I think something's going on between my refrigerator and my toaster in my house. I'm not sure. And what we're going to do is we are starting to interface more and more with the automation in our environment as if they were sentient. And listen carefully to what I'm saying. I am not saying that I think machines will become conscious. I actually have no way to know if a machine ever became conscious or not. But we're starting to interact with the machines as if they were sentient. We talk to Siri on our phones. We talk to all kinds of devices in there. I call them SAMs, sentient appearing machines. And in the electric utility industry, I think that more and more the generation, transmission and distribution and operation and maintenance of our power systems will be robo-sourced, if you will, to sentient appearing machines. And we need to take that into understanding as we move forward with our regulation. So, energy systems of the far future, to summarize my last slide here, multiple energy sources, ubiquitous sensing and computing, highly integrated between the buildings, the transportation, and the generation sources, a near zero carbon future, a complex prosumer relationships involved, and all moderated by sentient appearing machines and buildings. So, I left a few moments, although there's probably no questions about anything I said. John.
Hang on a sec, let's get the microphone. Yeah,
All right, thank you.
Roger, you always challenge our thinking, and this was very effective. The auto.
Mm-hmm.
You talk about introduction acceptance timetables. What's your current projection of when we're going to see a significant role of the electric vehicle in our life?
Oh, I think that will certainly happen within decades. You know, the penetration level is going to be very slow for a while, but you have like 18 different models of electric vehicles now. The infrastructure is basically in place for a charging infrastructure, and it all depends on the price of petroleum. Now, fossil fuels are going to absolutely dominate transportation for probably the next couple of decades. But I think you'll see transportation break into niche markets. Electric vehicles are very good for an urban environment, stop-and-go driving, and I think they will take a huge share of that market eventually. I think you'll see natural gas start to take the market for the long-haul heavy-duty vehicles. I think in certain parts of the world you'll see some biofuels, although biofuels in general I think have a very difficult process to gain market share. In the really far future, the hydrogen fuel cell will become more ubiquitous. But I think you'll see a low progression on electric vehicles for a while, but the manufacturing's in place, and it all depends on the price of oil. When the price really shoots up, then you'll see the urban invasion of electric vehicles.
Yeah, Roger, you briefly mentioned storage.
Mm-hmm.
And I guess it was Robert Heinlein that came up with the idea of the shipstone, that everybody has their megawatt in their pocket.
Mm-hmm.
And that being the true transformation of the whole energy cycle as we see it from application. What do you see as the role of storage, and what is the timeline for that?
Oh, it's a huge element, and I've got to modify this graphic up here. It's out of date in several ways. The biggest one being that corn cob up in for corn ethanol, which needs to go. But energy storage is in all three of these locations at different levels and at different pieces. And certainly in terms of technological advances, that's one of the major economic drivers. And I think that nanotechnology and some of the other advanced technologies will change the economics of that. It's going to take a while. But what you will see is storage at different levels, from utility down to the transportation, down to the building, down to the individual storage. And the key there is going to be getting them to all talk to each other and to transfer the power back and forth at the different levels of integration. But in the far future, one of the things we will become better at is matching energy types to workloads. And as we start to capture the energy flows in our environment, the light in this room, the piezoelectric vibrations, as well as the wind outside and so forth, and either use the electricity right away or storage in some medium, then we will truly leapfrog into a future utility. Yes, Mark.
Thank
Nothing,
you.
nothing about rates.
No. Roger, in the utility industry, we were always taught that your security comes out of your fuel diversity. You need to have nuclear and coal and natural gas because you never know what tomorrow could bring.
Mm-hmm.
And that is clearly changing, and our future fuel diversity seems to be dependent on gas and a variety of renewables. And I'm wondering if we, as utility decision makers, should be concerned about that change.
Well, certainly, and I had a colleague up in Washington the other day said that he thinks we're about to slip on the banana peel of natural gas as a single fuel source. And we talk a lot about diversity, but my experience, and I think yours in the utility industry over the years, is mainly you went for what was cheapest at the time. And gas is cheap, and it's going to stay cheap for a while. and you're going to hedge against it a little bit, both financial hedge and physical hedges with other type of fuels. But yes, it's a problem. One of the things this new system, though, particularly with energy storage and with decentralized and so forth, is the diversification of fuel sources is going to expand tremendously. And the good news is you have a lot more fuel sources. The bad news is coordinating all those different fuel sources. So I'm not too worried about diversification, except as a short-term problem that some companies will make the mistake of jumping in too much. Yes, sir.
I'm curious about the idea of what are called energy rebounds. The idea that as energy services become cheaper,
Yes.
technology improves, that in fact you're going to have ultimately, according to some people, increases in the actual amounts of both primary and applied energy consumed.
Yes.
And that this could have all sorts of consequences. There are some people who in fact are looking forward, breakthrough in Berkeley, for instance, and what they're arguing is you're going to have absolutely draconian price controls in order to control people's energy use because of the incentives that the cheapness of energy is going to be giving them. If not here, then
Yes.
certainly around the world.
Yes.
Do you have a problem with that?
No, I think that's absolutely correct. I think that, it's called the rebound effect. Some people call it the Snackwell effect. There's also, it's called Jevons paradox because of the British economist Jevons, who first noted that as the coal engines became more efficient, we started using more coal. And when you analyze this, it is absolutely a real effect. And you saw me say that we're going to become much, much more energy efficient in our consumption of electricity. You did not see a slide saying that our overall energy consumption is going down. In fact, I think it is increasing. I don't think that's the only reason. And I think it's, in fact, the study, I've done a fair amount of study on that. And I think that we do need to take all the energy efficiency estimates that are put out there by engineering specs and reduce them by about 30% or so as to what you really will achieve. And general purpose technologies that become energy efficient, like the steam engine and such, and the electric motor, can have enormous effects. We're switching over to LED lights right now, which are so much more efficient even than the CFLs are, and they're so much more efficient than the incandescent. I've seen studies that said that the lighting loads could increase by 10-fold with massive adoption of LEDs because we'll be lighting everything. So that is a very real impact and needs to be taken into account. Yes.
Time for one more, or if there-
Okay,
if not,
one
then,
more question. Fred?
I'll give you one, Roger. We must be spending too much time together because we're saying similar things. But there's one thing I still don't understand. I like your paradigm of someday we should be able to go Home Depot, buy a solar panel, take it home, and plug it in. We have the technology to do that today.
Mm-hmm.
If I could do that today on my way home today, buy a AC solar panel, a solar panel with a microinverter on it, and a 110 plug, and if I took that home today, put it on my roof, and plugged it into a wall outlet, what laws, what rules, what utility regulations would I be violating?
Well, everyone line up and yes.
And my point is, that is precisely perhaps what's going to prevent that from happening, even though we have the technology to do it today.
Well, or slow it down or delay it. And you know, Toffler in his book Revolutionary Wealth made a very good comment, and I'll end on this. And he said, you know, we've got this change going on, but we need to realize that change happens at different levels for different systems. And you can have technology change that moves very fast, and you can have policy change that moves a level slower than that. And then you have the legal system, you know. And the reality is that we're going to be dealing with the disconnects at different levels of our economy and society as technological change speeds ahead of economic and social policy. And that's the way it is. Thank you all very much.
Thanks very much,
Appreciate it.
Roger.